All right, Friday. Hello, Internet. Hello, Ben. How are you doing?
I've had a really crazy, stressful week, but it's been also very good in many ways. And I heard you've had a kind of similar week, which is why we didn't.
Yeah. And I'm a week older than I was, and at my age that counts because there's only so much water left in the bucket, and every day a day's worth of water leaks out.
Yep. I just realized I've brewed coffee in here. It smells wonderful, but I forgot to pour myself one. But I'll get one later. It's all right. It's all good. I cleaned up my office.
Yeah.
I should give everyone an office tour because I actually totally tidied it up. I was working till like 11 o'clock last night cleaning up because I have visitors. After our live stream, I have some guys who are a startup from Los Angeles, and they're driving down to do some work with me in my lab.
Oh, cool.
Nice. But I'm like, oh crap! Now I have to actually put things away.
Right.
So let me. I wonder if I can join on my phone. Right. I'm going to StreamYard from my phone, and I can give everyone a quick tour. How's that sound?
Yeah. Oh, yeah. Do that.
I've been promising to do this since I moved in here, and never got around to it. But here we go, people. I took out the trash.
Put out the cat.
Put a bunch of things away.
Clean up the spare electrons laying around.
How the heck do I get into StreamYard? Come on. Get it together, Ben. Oh, I have to enter a two-factor auth code. Oh my god.
StreamYard? Oh yeah, we shouldn't talk about your auth on the air.
While people are waiting for me to do this, what else? We were just talking about a bunch of things that are really valid.
Somebody just suggested talking about the fact you were just on the Amp Hour with David Jones.
I was. That was an unexpected pleasure. It was so nice catching up with Dave after It's been 10 years since.
Wow.
It's 2022. It's been 11 years since we were co-workers.
Right.
At Altium in Belrose in Sydney, and we had so many. Oh my gosh! Like people, Altium was a really cool, fun place to work and really stressful. And then it got weird when they moved headquarters to Shanghai, China, and it was still cool and weird and fun. I didn't move to China, and unfortunately, and Dave talks about our experience with the whole thing and what it was like. Like they were asking me to move there with no information. It's like we've made this. It's like they had just decided the night before. Nick Martin had just come to this conclusion the night before, and like the next day they were already pinging certain people saying, we're going to move to China and we want you to go first.
Wow.
And I'm like, so what allowance is there going to be? What's the compensation going to look like? Will I get an allowance for private schooling for my kids? Of course, they already knew my kids were homeschooled. So they're like, aha. Their answer is, oh, you can homeschool in China. Like, you can't even tell me what you're going to pay me and what it's going to be like. And
how long is the offer good for? You might get there 6 months and then they go, we changed our mind.
Well, I just knew immediately there's no way my wife and kids would agree. And they wanted to go back to the United States. We were living in Sydney at the time. And Altium were really good to me. They knew we wanted to come back to the States. And there was a guy, Matt Bergeron, who you know.
Matt, yep.
Hey, Matt, I hope you're watching. Matt is at Autodesk. Matt is at Autodesk, in charge of development for Fusion 360 electronics. So I was working with Matt for the last year and a half before they laid me off, but it wasn't Matt's decision as far as I'm aware, at least. But no hard feelings. It's all good. I'm happy doing what I'm doing now. So So Matt actually was here in the States working for Altium, and he wanted to be part of it. He wanted to chase the shiny object and work directly with the CEO and founder. So he went to Shanghai from San Diego, and they wanted me to move here to San Diego to replace him. So that we did a little switcheroo.
Okay.
But Dave actually, that's when he went completely full-time on EEV blog and has never looked back, and doesn't regret 1 minute. He's done so well, and he's so good at it, and we all appreciate him and what he's done. So it's kind of a cool story. But go back, if you didn't listen to that Amp Hour podcast, go back and listen to it. We talk about a lot of the weird, funny stories and crazy stuff that happened during that time at Altium and how turbulent it was. And go check it out for sure.
Right.
So, anyway, like you, Bill, you mentioned to me before we got on the air that I can't see our current broadcast on the phone, so I'm trying to figure out how the heck do I join from my phone. There's got to be a way to do this, right?
You want me to email you the link?
See, if I go into broadcasts, it says there's no current broadcast. Or no
make sure you're in the right one and not the wrong. Remember, there's two.
Oh, you are so right. I see it now. You reminded me.
Yeah.
I completely forgot about that. So what am I going to do here? I'm entering the studio on my phone, but allow mic and cam access. Sorry, people. It's the first time I've actually joined StreamYard from my phone, so please bear with us. So there were other things we were talking about today. On the Discord during the week, the discussion, this is a really useful, important discussion, especially for people who are trying to restore old equipment.
Right.
You're dealing with old devices, old CMOS chips, NMOS chips, TTL, and trying to interface them together. And the whole thing came up about pull-ups, pull-downs, fan-out. The word fan-out I don't think was in the discussion, but we call it fan-out, right? There's a fan-out.
And it used to be way more important than it is now. It used to be a boundary that you couldn't cross, starting with ECL and then TTL. You had a limited number of parts that you could drive from a standard gate, and then we had bus driver parts, which were good to like 12 mils. But the problem with the bus driver parts back then is they were asymmetric. They didn't drive equally well in both high and low. And then when CMOS made the stream, they're like 12 mil high, 12 mil low, just bonkers, drive the bus.
Yep.
MT branded DRAM in select P64s.
Everyone's constantly ragging on Micron. I guess they had it coming, right? We complain about Micron, but at the end of the day, we needed them to keep up with our demand. Wow, look at the part. Micron became the industry flagship after EdoDRAM, though. By the 90s, they'd sorted out their problems, and now they're the boutique memory company. But I'm sure they weren't back in the mid 80s. Yeah.
Well, so to tell the DRAM story, Commodore and Micron were really going at it. We were getting failures, and the culprit was both of us. The parts had a problem, but we also had a problem in their use. And we had RAS and CAS had real extended rise and slew rates, because they were putting capacitors on the lines to move them. But what it really does is make it tilt like that. But we noticed that 2 locations were worse than others. Well, that's kind of proof that it's the propagation down the signal path. It was the 2 on the end that would always do work, not always, but would typically do worse than the others. So that was kind of my proof that it was half us, right? The DRAMs were kind of out of spec, but then we were pushing the spec too. So in the urban legend is we go to sue Micron, Micron goes to sue us. We ended up coming to an agreement that everybody's happy with, and then, or nobody's happy with, one of the two. And then we ended up buying their Micron DRAM process to see if we could make our own DRAMs. And I just remember they were trying to bring in the polygons into our database. And they had problems with, like, in the corners where it wouldn't converge. It's like the two lines didn't quite meet. And we had a problem with a pre-charge time. And when we mentioned that to Micron, they're like, yeah, we have the same problem. So we bought a problematic DRAM process and tried to, you know, and this is the NMOS days that we were trying to do that. So I'm sitting here playing while you're doing that. I just happened to stumble across this. This is from a C128. Somebody mentioned talk about C128. Driver asymmetry was the reason for low active signals and driving by pulling the. Yes, driver asymmetry. This is, what is this? This took a regular VIC chip and turned it into the VIC chip needed for a C128. And one of my delay lines just fell out, but we couldn't afford delay lines in real life to make consistent delays, but we could on these emulator boards. These delay lines are like $4 or $5 each back then. And it actually has a tap for 10 nanoseconds, 20, 30, or 5, 10, 15. They're wonderful devices if you're trying to create control signals, but expensive. And so part of the problem with the Commodore 64, there was a race condition for CAS where it would come out of the VIC chip, and they would use that to switch the multiplexers from row address to column address. But then it's also going through the PAL, through the PLA. And if the PLA is too fast, the CAS will show up while the row and column addresses are still switching. So the C64 did something we don't like to see, which is it relied on a chip to not be too fast. And, you know, they're always trying to make chips faster. So this year, the chip might not be too fast. Next year, it might be too fast. So that was one of the issues we cleaned up when we went to the 128. So yeah, to show more of the emulator board, I've got some broken pins, but I'm not worried about those because I've got a box of these. So what we did was we took wire wrap pins and then we would solder a terminal machine screw socket on the bottom, and that would plug in nicely and not wear out. And then when we broke pins, we just put another one on here. You can see it's all wire wrap. And then the way that we would do resistors, discrete resistors and such, is do them on a dip header like that. So this, there was 3 of these, one for each of the original C128 boards. And let me put my delay line back in. So what's insidious about DRAMs, though, is it's not like the location. If you store to a certain location, if it corrupts, it's not like it's that location. That location may be fine, but you might corrupt at 18 other locations. So if you can imagine, troubleshooting DRAM corruption is kind of like being a holistic doctor. You got to figure out where all the sources that the problem could come from and find it. So we're seeing a good feed from you there.
You're reminding me, can you hear me okay?
Yep.
I'm just on my phone now. That reminds me of the first embedded systems class I had in college, and we had to build our own 6502 single board computer, and part of it was wire wrapping, and I hated wire wrapping. Wire wrapping was kind of, by then it was the early 90s and wire wrapping was on its way out. So everyone, this is my workspace. I've got a restroom in there with a K40 laser and some other mill. But I've tried to store everything up here, but I think it's in here. Dev boards. If I get that out, this is hard to do one-handed. I'm trying to be organized, but it's really tough.
Oh wow,
So I think it's this one here, and one of these days on a stream, I'm going to try and get some code working on this thing. But the problem is, the original designer of this was my teacher at college, and he's long since retired. I mean, he was already mid-60s in 1994 when I was in his class, and but it was a really cool system. They did their own ROM monitor. So I've got it in this old Mentor VGA case. This was an ISA, 16-bit ISA VGA card that was originally in this thing.
Remember high color, true color, all 15 bits for color, and then finally 16 bits.
Yeah, it took us a long time. Yeah, so this is partly wire wrap. So part of the class, and this was really, really cool. Part of the class was they gave us a partially finished kit. They gave us the PCB that the college technicians, the lab technicians etched these by hand themselves for each class that came through each year when they were in second semester and they had another class of maybe 25 students. They'd make up these kits, and these are the Rockwell chips you can see. It's actually a 65CO2.
Right. By Centertech, right? Oh, that's Rockwell?
It's Rockwell. That's the Rockwell logo on these.
Right.
And that's a CO2, but with a RS6522. That's what's that? 8K bytes RAM and the ROM monitor. It's a 27256. And as part of the class, we had to develop our own application that was interrupt driven. And there was enough spare room in the ROM monitor that we could keep the ROM monitor code and add our own code to it and we're allowed to use some of the routines that the teacher had put in the ROM monitor.
Right.
What was it? It's the ACIA down here. 6551.
6551. Right.
And here we had to add the 6551 and memory map it in. And we could actually choose how we wanted to memory map it on our boards if we wanted. Most people just did them the same. And we had to add the MAX 232 for the RS232 port, which is my RS232 port's wired in here because my first multimeter that I purchased out of high school, which is the one I still mainly use today, was a Metex, but it was branded as Dick Smith Electronics. And the reason it was $200 in 1993. And that was expensive for me as a kid.
Oh, but yeah.
The reason I bought that one is it came with this cable and it had holes in the side of the meter, and this was an RS232 port, and you could use it for data logging. So I actually just made that to match my multimeter cable. So that's what I used to hook it up to the PC.
Oh, cool.
Yeah, but the problem is that they didn't use standard commercial tools or off-the-shelf tools for development. The college wrote their own from scratch in IBM PC assembly language, all their own utilities that ran under DOS for even their own text editor for writing 6502 assembly language that would integrate with it, the other utility that would open the COM port and download your code and then jump to it. And so, we didn't have a debugger. We couldn't single step through anything. We just had to basically do printf debugging. For those who don't know what printf debugging is, it just means you manually add code in your code that triggers certain external events that show you what state it's all in,
Right.
And
by printing, by doing printf coming from format print in C language is where that we get the term from, right?
Yeah. So if you're writing embedded code in C and you don't have a debugger or a debug hardware, you can manually add your own debug software in your main code to output things to tell you what it's doing at different times. And
right.
Yeah. So this is my first ever personally owned. I believe it's the first ever personally owned single board computer. There might have been a Z80 one I had right around the same time, which I think is still in the basement under my parents' house, and I need to go get it. Or maybe I sold it to another student used. I don't know. Don't remember. But so one of these days I'm going to try and, I know this all works. It flashes an LED sequence on power up, which it's meant to do.
Okay.
So it all still works. I just don't have access to this. I don't believe, but when I go back to Australia and visit my parents, I'm going to look amongst all my old floppy disks and see they're probably covered in mildew and unreadable, but hopefully somewhere I have a disk that has the original DOS utilities for working with this board and the, some of the other code and stuff. But yeah, so everyone, this is the Jordan DSP studio, and you've seen parts of it already, but it's finally neat and tidy and ready for someone to sit down and have a coffee with me. Anyway, I'm going to go back to the main desk, and we can talk about, because this was something interesting that came up in Discord this week. Woohoo! Whoa! Here's the infinite screen of doom. So I'm just going to add myself back to the stream here and take myself out.
Yeah, I'm actually over in the corner of my lab. You just inspired me to pull something out. Well, that sucks.
Hang on. Okay. That's gone. Where'd you go?
Yeah, I'm working. I'm pulling something out to show you. And I just dropped something right on one of my desoldering tools. Did I see a cassette deck in your rack?
No.
Oh. Well,
but I did have a really nice one back. So Mondo, what's my history?
This was my pride and joy. When I was
beautiful, the TX.
Yes,
those are really beautiful.
It was the first around the first time when metal came out, metal tapes.
Yes, right. That meant it was the film on the actual tape. The magnetic film was. How was it different? It was made of metal oxides, not.
Right. It could handle more current before it saturated. So you had a wider dynamic range on metal tapes. So it's metal. It's got iron in it, right? So you could put a higher density of flux in it.
Yeah.
So we're talking about wire wrap, and I just went to, so my original wire wrap tool belonged to my ex-girlfriend, and it was an electric one, and she did wire wrap like beep, 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 beep. I mean, she did stuff like this, like in the morning, And I go to pull out my 30-year-old wire wrap tool for a Hackaday article, and it's just broken inside. It's under pressure, and all the plastic turned brittle. So I bought a new one from Oki for my Hackaday article. The Hackaday article is a couple years old now, but this is one where you would squeeze the handle to make this rotate. Well, it too broke. You can see this whole piece is under pressure. Just sitting in the drawer, it broke from the spring pressure on the squeeze handle.
Terrible. And those things aren't cheap either.
No, it was.
I had wire wrapped with a hand tool. It was like a little screwdriver.
Yes.
Like a hollow tube with notches out the side. And the thing about wire wrap, like I didn't understand this till the teachers explained it to me, because I thought this is such bad old technology. Why would I do this?
It's actually not.
Actually, the connections are more reliable.
Yes,
if it's done right.
That's right. That's right. It's got a certain number of windings with the metal cutting into the corners of the post, and then like 2 windings of insulated, so it's a total of like 6 or 8 windings. That's all prescribed how you do that. And so it even acts as its own strain relief. Yeah. Here's a couple of those little things you were talking about.
Yeah. So I teased
It's got the little built-in wire stripper, so you put your 30 gauge in there and pull it.
Those are even luxury ones. Mine didn't have that. They had, and mine were just plastic cheapies, like the cheapest you could get.
So and there's a wrap and an unwrap side to it, so you can sit there and also twist them back out. And I've done boards doing them without a tool, but I'll tell you what, a tool makes it better because the tool will automatically do the right number of turns. So even that squeeze tool I had, if you loaded that, you would load it by putting a wire in here. I think it's like an inch strip back, and then squeeze the handle. It would and it would do the right number of turns. And it is a very reliable connection. I'll bet these connections are still good.
Oh, they would be, for sure. Yeah.
The only problem you get, not the only, but the major problem you get is when you strip your wire wrap wire, if you nick it, then it'll break right where that nick is, usually under vibration and heat or something.
And it was very, very thin wire that was, it was copper, but silver plated. Right. So Corsairs, I'm sorry, I don't know how to pronounce that name. Kersar, you'll have to tell me.
Its instruction set exactly the same. It's the same due to licensing. My understanding is it would be the same as the original WDC 65C02, but that's different than the NMOS 6502. But I'm not heard of any manufacturers making up their own code because that's just it breaks things to do that.
I've heard in another stream someone mentioning that it might have had some of the undocumented stuff was actually documented by them, but I'm not sure. I'd have to compare the data sheets one time. I ain't got time for that. But talking about data sheets, right?
Right.
So on Discord this week, what came up was that whole interfacing thing.
Right. You were talking about pull-ups?
Yeah, there was a discussion about pull-ups and things. And I was just curious, like, if we could compare some data from Bitsavers, say, to modern, because here's the thing, and we've talked about this before too. Every semiconductor company that keeps those CMOS and TTL families going, every now and then they want to get more. They change process node, not just for their ASICs, but also their off the COTS parts. Because hey, if you can double the number of chips you get out of one wafer, why not? That's more money. So they keep shrinking the dies, but every time they do it, the characteristics of the analog characteristics of the integrated circuit are modified.
Right. And
so they have different revisions of the data sheet. So you could download a data sheet that might be a revision 0 or A, or no revision noted, the first data sheet for a 4000 series part. And then what you get is very different, because what you can buy now it's actually not the same part. It's the same logic function. So where'd you go?
I'm looking for a data book. You mentioned the CMOS. I'm looking for my RCA CMOS data book.
I'm going to bring up an 83. I've downloaded this from Bitsavers, which is a 1983 National Semiconductor. Let me see if I can open this.
Yeah, I piled a bunch of stuff in front of 2 of my shelves, so it's actually hard for me to get to 60 of my books.
I'm gonna share. Actually, I'll put this on my other monitor. So I'm gonna be looking sideways, everyone, but don't look at me. Look at the.
Oh well, look at the book I just found. Rockwell System.
Oh, look at that, 85.
1985.
Oh, hey, that's probably got the 65CO2 part in it that I was just looking at.
Let's take a look.
Yeah. This is the one I pulled up. I downloaded this from Bitsavers. So if people don't know, if you need old data sheets for parts that are on old boards that you're trying to restore, this is the place. They have everything there almost. They have a lot of stuff. It's a I forget the name of the person who created the site, but it's a labor of love and great benefit to all of us because people have been sending old data books. He'll scan the whole thing in digitally and make PDFs, and they're all available for free download on bitsavers.org. It's incredible resource. So, yeah, so I'm getting confused by my mouse pointer because I'm seeing it on StreamYard and on. So what do I want to do? I want to go view page display. Let's see if I can do 2-page view. Let's find a part that's something people would need to use today. So but there's just a lot of really good. These books were awesome because they came with a lot of really good learning material in them, like these app notes and talking about general principles of CMOS, for example. Like this all talks about power dissipation in the circuit, and they probably talk about HC, CMOS, and TTL, and yeah, they're comparing all of that. They talk about fan out and all of this. The processing, this is incredible. Like they're telling you how do we make this? This is how we make it. We start here and we build up.
Start with a substrate.
It's like if you want to do the course on 0 to ASIC, I'd even before doing the course start by reading National Semiconductor AN 310 and others like it because they explain the whole process to you.
Oh wow,
I
didn't know. It's
just cool, super cool. Speeds. They talk about switching speeds and what's this one? Power supply voltage and I/O input voltage. So there's bands of how CMOS works. There's guarantees of based on the power supply voltage being standard, what your input voltage range needs to be. These are absolute maximum ratings, right? So, but they teach you all about CMOS in the beginning of the book in every way. But this is 1983 CMOS. So CMOS today is a lot faster, a lot smaller, a lot lower parasitics and things. And then they've got the standard pinouts, just such a great resource. Okay, so now let's find an actual, I don't know if there's bookmarks in this. I don't think we have the bookmarks. No, because it's just a scanned book. So I'd have to go through, but let's find 74HC00 quad 2-input NAND gate. So what we're looking at here, and let me zoom in some. Power supply range 2 to 6 volts, even in 83. That's pretty cool because these were good for battery powered stuff. That's what CMOS was touted for. And we get the typical absolute maximum ratings. Now 4000 series CMOS is a bit different because it was meant to be able to be powered up to 16 volts. And so 4000 is good if you're doing a lot of analog and digital interfacing, but it always comes with trade-off. If you have a technology that allows you to power it up to 16 volts, you're going to be limited in speed, switching speeds and things like that, because you have to have thicker insulators in the silicon. That's how you get the greater voltage withstanding, is you have thicker insulators and some other differences in barrier dopants and so on. And so all of that means you get a slower device because there's, anyway.
Right. So I have a story for that. Hang on. Yeah, I'm running for another part. We, while making chips, back in the 80s at Commodore, they added, the chip is 5 volts, right? 0 to 5. And they were switching at that speed for them. Then they added what was called back bias. They wanted to drag the substrate 2 volts negative. And what that would do is cause all the gates to pinch off even harder. So at rest, it would pull less current. But now the voltages are trying to swing 7 volts. Guess what? It slowed down. Guess what? They did it right before a CES show. So they endangered the CES show. Yeah. And what I found was that pin right there, that little notch. Here, let me expand this a second.
Yeah. That
little notch right there is the substrate.
That's the lead frame.
Yeah. So I put a scope on there, saw the negative 2 volts that was giving me the conniptions, and I grounded it to like one of the corner pins here, grounded out the substrate, and it started working again. But when the chip designer saw that I had grounded out his back bias generator, you'd have thought I had just killed his kitten or something. He looked at me like, "Arr!" I'm like, it's got to work for CS, man. I don't care about current consumption,
So he was like, you're pulling tons of extra current and probably going to...
I'm just grounding it, right. Who knew that was the 41st pin, right? I mean, just the fact that was the kind of answer we came up with was just so typical of the run-up to that CES show. So, hey, somebody asked about the the Rockwell 6502. Let me see if I can pull it up.
Oh, yes.
So they asked about the instruction. Why is that angle so weird? Anyways, this is the Rockwell. But right here is the BBR, branch on bit reset, branch on bit set. And there's a note that says instruction not available in the NMOS family.
Right.
So there's the answer to your question. It was definitely programmed in by...
Hang on. Show us that. I couldn't see that properly, Bill, on your... There it is. That's it.
BBR, branch on bit reset, branch on bit set, and it's got a 1. And down here it says not available in the NMOS family. So it was definitely a... why is that?
And note one, there's quite a few instructions that are not in the NMOS family. There's also push X on stack, push Y on stack.
Yeah. We had to transfer those
pull X, the old days. Y. Wait a second, then. In that case, if there weren't... So so riddle me this. In the Commodore 64, the 8510 or 6510, that means that did not have X and Y push and pull either. So
no, you would whoops. Let me.
Yeah, so that meant if you were doing a demo, you were forced to use the
TXA, push A, TX.
You're forced to use 2 extra instructions.
Yeah.
Which could have been like 4 extra cycles or something.
Right.
Well, that sucks. But hey.
That was
more kudos to the demo scene and people who did those demos, because you had to bum every single bit of power out of that thing you could.
Yeah.
I can't imagine having that much patience to be able to focus and concentrate on something so long to get it so good. Oh,
that was me. I'm trying to troubleshoot why my book is keystoning when I show it, but
yeah. So I guess that confirms. Yes, that is indeed true. That
right.
You can execute. It's not 6.5 CO2 code is not backwards compatible, but it is forwards compatible.
So now the only people I knew doing the undocumented code back at Commodore in the early 80s, mid 80s, was they used it for copy protection. They're doing something outside the box anyways to copy protect a disk. By the way, somebody asked if we had an 8-inch disk. Not that I know of. But so to me, that was like, well, you're already outside the box. They would do things like write to track 0, which is normally unwritable. They would actually introduce a CRC error and look for the CRC error, and because the disk copier would correct the CRC error. So they would manually put a CRC error on the disk, and that was part of the copy protection. All kinds of funny things like that. It was just cool.
Yep. So you could argue, in essence, it's true. You could argue 6502 was a RISC. Strictly speaking, if you go only by the number of instructions criteria, it was. Yeah. There's more to it, I think.
It's kind of risky compared to these days. Yeah.
Yeah. A true modern RISC architecture, and this is what we were talking about a couple of weeks ago with the Jepster, Jonathan Pallant. Hey, Jonathan. Thanks again for joining us, by the way. It was a cool episode.
Yes, that was very cool.
Architecturally, there's some other differences about RISC, like the ARM architecture. ARM used to mean Acorn RISC machine.
Right.
But somewhere along the lines, the Acorn brand died. They couldn't compete with the PC market, just dominated everything before Apple came around again. And PCs still really dominate. But they had this IP because they developed this beautiful RISC architecture. And guess what? It's everywhere. They won.
So yeah, Bill Mensch talks about that, and he's still using 6502s in solid state drives, for example.
Why not?
Part of the support.
Can you imagine if you make a 6502 in a current process node? Can you imagine how fast you could make that thing go?
Yeah,
you could. We could make a 6502 multi-core on a switch fabric with each core having its own instruction cache and some other stuff to go around it. Could you imagine, like, you could have hundreds of 6502 cores on a single chip?
Yeah.
All just like going nuts, doing different things.
And you could improve it, like give them register arrays, like Eddie D is saying, yeah, not enough registers. In the lack of registers didn't hurt an interpreted language like BASIC as much as it hurts a language like C that's precompiled, where the compiler wants to use register 16 for something and register 17 for something in the setup.
Whoa, what happened?
What's up? We're still here. Yeah, I'm here.
Bill, did we lose you?
No, I'm here. I'm here. Hello. Can you see me? You're frozen. So we've lost Ben. Oh, so while we're talking, here's another data book I found just as I dropped something onto my desoldering tool. Here's an entire data book from National in what year is this? 1993. Just about real-time clocks. So real-time clock handbook from National. I should probably find a way to give these away to people or something. I've got quite a collection of this kind of stuff. So you're moving a little bit. Can you hear me?
Yeah, I heard that. I don't know what you're yellow.
I look okay on, I'm watching it in two feeds, but
no.
Bill is fine. Ben is frozen. Ben is back. That's what people are saying on the.
Yeah, I don't know what the hell's going on. I'm paying for premium business internet connection. I'm on 100 up, 100 down. We could freeze, and I would do a speed test on Google, and it still says I've got 120 megabits per second upload.
Right.
Like, what the heck, StreamYard?
Of course, if the speed test actually worked, during the speed test, you would have no bytes available, bits per second. If it were truly filled the pipe to measure the pipe, there'd be nothing left in the pipe. 8088 was an ugly instruction set. Yes, I've always thought that.
Yeah, it's kind of the irony of this world that we live in. Haven't we all looked at someone who's maybe a famous entertainer or a CEO of a company and wondered, how on earth is that person successful? Because I'll tell you what, they don't qualify, or they don't they don't check all the boxes for me, right? Maybe they're mean to people and or maybe they're not that bright, but they seem to have just gotten lucky, and you wonder, we all see those people in the spotlight and wonder how the heck they just had an inordinate amount of luck one day. You also meet a lot of people who worked really hard to get there and they deserve it. But it's the same. It's the 8088 is one of those things. It's a turd. There's no other way to put it. And because of great marketing and branding, it succeeded anyway. And because of backwards compatibility, it became more of a turd over time. And now we still have it buried deep inside the Intel, whatever the current generation Core i7s and i9s are.
Right.
So it's pretty ridiculous. Yeah.
Here's the 68K is a beautiful CPU. We thought so.
We
were like, oh, and they came in those big Hershey bar chips, the 64 pins, and we were like, oh, you'd find us licking them and stuff.
Every engineer who's an engineer who's worked with them has loved them. It's true.
Right.
This
I didn't know about. I thought the bus was.
Well, that could be true.
It's locked. No, it could be true because it's locked to the video refresh rate. Yeah.
Right. And the MMU, and all the fancy stuff was really done by the custom chips.
Yeah.
Really Agnes doing all the heavy lifting. Without Agnes, the Amiga wouldn't have been a quarter of what it was.
Right.
Agnes was the magic.
Right.
And there were tricks. I'm sure people in the demo scene during the Amiga era could get both working just as hard as each other to really pull off some magic. Yeah.
What blew me is people will use the term fat Agnes, and I'm wondering, how do you know that word? That's something we said internally. Then I finally saw it. Somebody put it right on a PC board. It actually said fat Agnes on them.
I've only ever known it as that because that's what my friends in the late 80s, early 90s, when we had Amiga 500s in Sydney, that's what we were calling it.
Yeah.
It's what I was introduced to it as. I think in the schematics in the back of the user manual, they actually had the published schematics. It just said Agnes, but yeah, on the PCB, it was labeled.
So my memory is Agnes came to us with the chipset that we bought from, the Atari spinoff, and Fat Agnes was Commodore customizing it. It's like the first thing they broke the die open and went in there and manipulated. That's my memory. Haney might give me something different on that.
Yeah.
Engineers and chips. What's this? Somebody's
was.
Yeah.
Found a new chip that could replace 3 others in the Apple floppy controller.
Oh, we used to live for finding that right combination of customization that was still not too specific, because you don't want to design something in so specific that if it doesn't work exactly right, you have to throw the whole thing away. So it's nice to have a building block that's pretty specific and yet you can still tweak. So yeah, Woz was pretty. That's what we knew him for back in the Commodore days, was the WSM, the state machine that was in the floppy controller. We're like, we didn't know how to pronounce Job's name. We thought it was Job, like in the Bible, but we knew how to say Wozniak.
That must have irritated him so much.
Yeah, well, I didn't talk to him, so.
But I think a lot of people called him Steve Jobs.
Yeah.
Didn't know.
Back in the day, yep. And it's not like you could jump on the internet and see how to pronounce it correctly. If you get it wrong, you'd never know.
Yeah.
All right. Here's an interesting one. I got no problem with 6809. It's a 6502 from a different company with different, different things. Similar architecture.
6809 is more of a microcontroller. It's more of a microcontroller, but it's used. It's so similar. It obviously derived from the 6800, but 6809 is also still used today. There's current generation 8-bit microcontrollers that NXP or Nexperia or whatever the hell they want to call themselves today. So, Nexperia was NXP. NXP was Philips, so the Dutch microcontroller.
Yes, Netherlands.
Yeah, yep. They acquired Freescale. Freescale was a spin-off from Motorola for the semiconductors.
Oh, I have Freescale manuals. Yeah.
So anything that was 6800 or 68,000 and later derived and then some of that became PowerPC as well, ended up being rolled into Nexperia. So they still have 8-bit microcontrollers, really tiny ones that compete with the STM8, and those are all descendants of the 6800, and basically, in essence, the 6809. And there were a lot of variants of that were really, really popular, like the 68HC.
Yes, HC11, 68HC11,
and 68HC705 were others that have been used in a lot of popular, just really cool microcontrollers. And the 6809 was used in a lot of the Japanese. The 6809 and that whole family was licensed out to Japanese chip manufacturers. So there's Hitachi. There's Hitachi processors and microcontrollers that are also 6809s. They're the same instruction set. And those are used in the retro Roland gear that I love so much. The guitar processor, the Roland GP8,
right,
has an HD6303. And the HD6303 is Hitachi's version of a 6809, but with a whole lot of extra peripherals on it, like ADDs and all sorts of stuff. Yeah.
Right.
Yeah, they called it, I don't know why, but they started them with the 63 prefix instead of 68. If you look at the NEC licensed parts, and NEC NEC was the Japanese producer that had license deals with Intel. So they did microcontrollers following Intel's family, like this 8051. And before that, even the 8048 family. So I have some of those too, that the NEC made but they used the same number as Intel used, just with a different prefix and suffix. So yeah.
So I've got
9 was a really nice microcontroller.
Okay. So I've got something to show here. Let's see if you can see it. This is how I learned about a bunch of the, I don't want to say competition, but computers in the old days. This is given to me by Benny Pruden from Commodore. This back, look at
wow, look at that old business card.
Right. And in here, we've got different kinds of computers, like vector computers and data flow. And when I go to look in here, I find, here's how a Cray computer works.
That's so cool. It's
got Sperry, it's got Burroughs. It's like, I didn't realize Sperry and those guys were like 17 bits, or I forget I used to know all that stuff. But this goes into all the different architecture. Here's the 3200 series in NSC by National. So here's how, this is really a cool book. If you're into there's VAXs. And then it talks about things like memory management and stuff.
Is it possible to still get that book, or could you, because that's all separated, that's ready for scanning.
Yeah, I should scan this.
Scan it, or send it to Bitsavers, and they can scan it and send it back to you. But this reminds me of my university study guides for and lectures for computer architecture and algorithms and data structures. This is like a brief combination of two different topics, because we looked at the hardware architecture, which is all about what is RISC versus CISC, von Neumann versus Harvard, what is an ALU, what are the basic components you need to have before you have what you can even call a CPU, and how do they work with each other. And there's that, but then there's also, okay, now you have that, how do you write the software? What are the software structures and architectures that operate on it? So that's where you talk about graph theory, queues, lists, binary search trees, and and all the algorithms and how long the algorithms take to do things, and then you do all of that, and then you go into the operating systems class and see where it's all.
Look how thick that is too. It's just chock full of computer architecture.
That needs to go to Bitsavers.
Yeah. I remember as a kid, in my 20s, sitting down and reading that thing page by page, and because I didn't have a normal education, so anytime and there was no internet, so anytime I got my hand on a source of information like that, you sucked it up.
Oh yeah, I have a mental image of you with your long hair and your short
and no shirt on. Yeah,
and no shirt on, sitting in bed late at night. In bed late at night, turning the pages and with a highlighter. Right.
Yeah, I would lay in bed and read one side, flip over and read the other side. It's like, and if you saw pictures of my bedroom from back then, getting to the bed was tough. It was just surrounded by books, and a lot of them like science fiction paperback, but then piles of data books. And then when we would go on vacation, I would shove every nook and cranny in the old car, the old Datsun Z, with a data book, because I read them for enjoyment. I would sit there, we went down to Kitty Hawk, whatever can't remember the name of the place where Kitty Hawk flew, but
that's the name of the beach, though. Is Kitty Hawk.
Yeah, but there's a name for the island and stuff. But I just remember taking all my data books with me and stuff. So everybody's on the beach, and I've got a data book.
You're a true engineer.
I loved it. I loved it. I'm from a small town in Indiana. I wasn't supposed to have a future, so I accidentally, kind of bumped into one.
Yeah. Well, when you love something and you're really made for it, it's like it's the same with you as, and was said this in his autobiography. He said this one chapter where he says, when this one thing, when the Apple One happened, he's like, everything in my whole life had led up to that moment. It's like, it just felt so right. And the same thing I could say, I'm sure you felt that exact way when you had that first interview at Commodore, and you'd actually been working for that instrument company.
Right.
The scale company, and you'd done, and you're like, you're there, you're in, you're like, wow, you look back, everything was to get to this moment. This is it.
It all fell into place. Yeah.
Right.
Yeah. So because of a certain book, you talk about that cascade of events.
Yeah.
Right. Because of a book on ray tracing, I have a son. Right.
Oh yes, you've told this once before.
Yes, I did.
Tell the story again for people who haven't, because that's a great story.
Yeah, I was walking. Remember when they had software GameStop type things in the mall? So I'm in the mall. I'm walking by a rack of books, and I had actually walked past, but my eyes had seen Persistence of Vision, Ray Tracing 2.0, the book. And so I bought this book. I go home, and there's no internet yet. I loaded the disc that came with the book, learned ray tracing.
Was that with an early version of PovRay?
Yes, version 2.0 of Pavre.
The Pavre is still there. You can still,
yes, it is
still maintained. Yeah.
And if you Google Bill Hurd and Pavre, you'll find like articles I wrote from back then. And it would run overnight, for example, to do something, right? But I made a spinning logo for ADP, the company I worked at.
Yeah.
Pretty soon, everybody's got one. I mean, it was nice. It looked like red brass spinning over a granite floor with a black background. I mean, it looked classy, right? And it's ray traced. Well, they introduced me to a video guy who's making their kind of like one of their infomercials for him. And they said, well, you should, here's the guy that did the ray tracing thing. So me and him became friends. And one day he says, well, would you like to meet a girl? And I'm like, no, too busy. It's like, and he's like, no, she's, she works in an animal hospital. You're doing the emergency medical stuff. You two would get along. Well, bottom line is we did. And because I got that book, learned ray tracing, met Chuck, our friend, I met Cindy, my wife, and now I have a son. And I remember the moment where I stopped and backed up and bent down and pulled that book out of the bookshelf. If I hadn't done that, my life would be different.
Wow.
And that's just weird to think because I remember the moment.
Yep. Totally. So good.
Yep. Oh, so there's still one of my favorite data books since we're pulling data books out. 1981 TTL data book for. So I gave one of these to the guys in the lab at Commodore. But I had coined the phrase lab trash one day. I said, well, it's not like you lab trash. And of course, that never went away. They would always be like, well, us lab trash. So I gave the book to a guy, but I carefully penciled it out. And it said the TTL data book for, instead of design engineers, it said lab trash, So they had a hardbound TTL book in the lab. And the only thing was they had to put up with that insult every time they saw it. And it was just a running joke because obviously I was lab trash. I was from that environment, So, hey, I've got a thing about the book that Margaret and I did like a year and a half ago now, a year.
Yep.
We've been talking about doing a hardbound version of that and maybe collecting more stories, make it into a collector's item, and get stories from Haney and
sign them.
And sign them. Right.
Yeah.
We would, but one of the things I want is more pictures. We didn't take pictures like they did out west, right? In Commodore, there's hardly any pictures. So I'll tell anybody that's watching, if you got pictures of that would go good in a book about Commodore, join our Discord. Ben, tell them about our Discord.
Yes, we have a Discord. Our show is called the Coriolis Effect. Because I'm from down under, although I live in the States, but that's the joke. But go to Coriolis.
From up over. Yeah.
Yeah, go to Coriolis-effect.com. There's a link at the very top that says Discord. Click on that. That's the invitation to our Coriolis Effect Discord channel. Many of the people on today, I recognize names from the Discord and from past streams. So thanks for coming back and joining us. And join the Discord because there's a lot of it's actually really taken off lately. There's a lot of discussion going on around retro computing in particular, but also electronics in general. And these are the things we talk about. But yes, there's a few specific channels on our Discord, and it would be fantastic if you have photos of inside Commodore photos, retro photos, whatever, anything that would suit,
or especially period stuff from the 80s. Yeah,
especially from the 80s. If you have images that you could scan in, or stuff that you still have that's good enough to take a photo of now, it's all helpful for Bill and his.
Yeah. So what I want to do is
second edition, huh?
Yeah, you think of this as the feeler phase where we're doing the analysis of whether it makes sense to do. But, I kind of got my whole thing behind it was I wanted to write all the stories down while I still remember them because my memory's just gone to crap.
Dave?
But now let's get the stories from the other people,
Dave says we should do T-shirts. Dave, I agree. I've been harassing Bill about this now for about 3 months, saying we need some swag that
we need a logo first.
What we're doing.
Yeah.
I've been trying to convince my son, who's really graphically talented, to do a logo for us. And I'm like, I'll pay you, dude. Like, I'll pay you. And it's just, I don't know what it is with teenagers, getting through to them to actually have them do something. I did a bunch of pencil sketches of ideas and stuff. And I'm like,
I got somebody that can do the logo and do a good job, but I'm waiting for you to do the family thing first.
I'm going to give him an ultimatum. Say, if you cannot do this weekend, somebody else on Bill's side is going to get paid to do it, and you'll miss out.
Yeah.
But we'll do some t-shirts and other stuff for sure. So stay tuned.
Right.
Yeah.
maybe give away data books as prizes, things like that. There's a whole bunch of stuff we haven't touched on. So.
Yeah. Well, so here's something else, Bill, that we haven't talked about, and I'm just throwing it out there live. So this is risky, and I'm not making any promises, and I know you're busy, I'm busy, but we should do a project together. We should actually do an open source. We should do an open source design together. That's our Coriolis board.
Yeah.
I don't know what it should have on it. So this is another thing. Maybe we won't do this, but I think we probably should do something like this. So I'll put it out there. Get on the Discord and tell us.
Rub it in.
Wire on a t-shirt, perfect. That's a thing.
Yeah, it was a kludge, but it was a good kludge. It saved my life.
Yeah, that's definitely a thing, Chris. Brilliant idea. We should do an open source design together. We'll collaborate on it. We'll use ACE365, and we'll. Or maybe we'll even use KiCad. I mean, I work in Altium, okay? It's what I know, it's what I'm experienced in, and I'm very
It's a heavy lift, though. The KiCad would be a cool thing for open
KiCad has come far enough that I'm actually willing to start learning
it.
Just so I can help collaborate on other open source projects if the opportunity comes up.
Well, if somebody writes the code, we could do something like 8 or 16 6502s all running loosely coupled, make a multi-processor out of it. But somebody's got to write the code for that, right? So,
well, we could do
the hardware.
Is do an FPGA. I feel like all of this has been done, but we could do our take on it. We could put an FPGA on a board and put a bunch of 6502s together in the soft core would be the normal practical way to do it. I don't have the money to do this course, but I one of these days set as a goal to do the 0 to ASIC course, but it's quite expensive. Yeah. It's cheap considering what it is.
Right.
It's much cheaper than doing a master's degree at university. It's a fraction of that cost, which is what you normally have to do if you want to become an ASIC designer. You have to go do a master's degree, and it will cost you $50,000 to $200,000 depending on what university you go to. The 0 to ASIC course is a much better option financially, but
aren't the chips free that you make? Doesn't he use like the Google channel?
There's tiers. The cheapest course, you just learn how to do it, but you don't. You get to get in a waiting list for Google's free wafer space.
Right.
But if you pay the extra, you get extras, and one of the extras is a guaranteed spin.
Okay.
So
cool. So currently 10 minutes after the hour. So
goodness. We were worried we'd not have much to talk about today, but we
can't do this every time. But it was good to take a break and And by the way, if you want to be on the Coriolis Effect and have something to say, show, talk about, join us in our Discord, and we'll set you up. We'll get you on the Discord.
Yeah, join the Discord and start posting images and type share with. There's a projects channel in the Discord. Join the Discord. Get into the projects channel. Show us what you're working on. We'll probably, if you do that anyway. But if you do that and you're also into joining us on the stream and talking live. Not everyone likes to do that. I get it. But I'm sure there's some of you out there.
We'll be gentle.
Yeah, some of you out there who'd be really happy to share what you're doing live with us. That would be awesome as well.
Just even a tour of a workbench. I think, I know that especially when I was first getting into surface mount, I really enjoyed seeing other people's surface mount approach. The bench, they're just all the things they did that was different than the through-hole days. Yep. So I think it helps to see other people's workspaces.
Yeah.
So excellent. All right. Well, we'll see everybody here next week. We don't know what we'll talk about, but we'll figure it out.
Well, hopefully, I mean, Dave Jones did say he'd join us, but I'll just put it out there again. Just because of the time zone difference, we'll probably have to pre-record that one with Dave. So that could be next week or maybe the week after. Which just that I'm still working with Dave to find a time that works for him to do that. So keep your eyes out for that one as well. And yeah, thanks for joining us again. This is cool.
Yep. So we'll see everybody here next week, and y'all have a safe weekend.
Yes,
I'm very serious about that. So take care, everyone.